Disabled people are not only limited because they have a medical condition affecting their physical abilities. More importantly, they are limited because they don't have access to education, employment, or public services. Their physical disabilities limit their access to technology and therefore social integration. This exclusion leads to depression and poverty, which makes them feel vulnerable as they lack the knowledge of basic subjects that are important because of their condition, such as nutrition, managing their illness, and ensuring their safety day to day. Because of their physical limitations, something as normal as typing a letter in Microsoft Word, chatting with a friend on MSN, or doing a simple Bing search is not possible for many disabled people. We at Lifeware don't believe that these actions are impossible because they're unable to move their limbs, but because there isn't a technology designed with their specific limitations in mind, which will allow them to access a computer and connect with the world. Today, approximately 10% of the world population, more than 677 million people, suffer some sort of disability, 80% of which live in underdeveloped countries. Our solution will reduce the impact of living with a disability and will allow them to use computers through which they'll have access to education and employment, ensuring them a higher quality of life. Individuals in underdeveloped countries could also contribute to their economies because with the ability to control a computer, they could work in positions such as telemarketing executives or call center operators. As long as computers have existed, they have been inaccessible to many disabled people. The difference today is that technology has become increasingly important in our day-to-day life. Computers and the internet are used by more than half of the world's population. We are living in a digital era without precedent. Therefore, we are obligated to ensure that all people have access to these basic tools, regardless of their physical condition. Currently, there are few solutions to this technological inclusion problem, and those that exist have failed to penetrate markets in underdeveloped countries because of their high cost, the limited awareness of such technology solutions, as well as the lack of government support. This is the problem facing people around the world who cannot move their limbs, and this is the challenge that we have accepted. Our solution is LifewareIntegra, a totally innovative software that takes advantage of cutting-edge technology to make the user's physical limitations a non-issue, enabling them to use a computer and the internet no matter the degree of their limitations. LifewareIntegra includes a set of tools that enable complete access to a computer and its applications. The interface allows interaction between the user and the computer without the need of constant assistance from another person. LifewareIntegra uses Epoch, a device developed by Emotive Systems. This headset went on the market at the beginning of 2010 and was produced to increase options available in video games, supplementing traditional handheld controllers. Using the latest developments in neurotechnology, Emotive's Epoch is a high-resolution neurosignal acquisition and processing wireless neuro headset. It uses a set of 14 sensors to tune into electric signals produced by the brain to detect thoughts, feelings, and expressions, and connects wirelessly to most PCs. It also contains 2 gyroscopes that let us know the exact position of the user's neck. LifewareIntegra connects the inputs from Epoch to the actions on the computer, simulating the functions of a mouse and keyboard. These tools, made to be used by mobile, functioning limbs, are controlled through simple movements or thoughts as long as a person has the capacity to make the slightest movement, as minor as a blink, he or she can control a computer. What differentiates our solution from all the others is its capacity for personalization. It can detect the expressions, movements, speech, and thought patterns that are best suited to the user. LifewareIntegra has 12 different facial expressions: raised brow, furrowed brow, smile, clenched jaw, smirk left, smirk right, laugh, blink, wink left, wink right, look left, and look right. And because our software reads and records neurosignal patterns, with enough training and mental stamina, a user could train him or herself to produce a specific signal pattern. These think patterns enable users to control the computer without movement or voice commands. Though our software is a solution for a problem affecting a select group of people, the impact it will have on their lives is enormous. Many people with limited physical mobility can't leave their homes. We created LifewareIntegra with this group in mind, and with the self-imposed mission of breaking down their barriers and giving them access to the world outside of their homes through the computer, so they can chat online, listen to music, operate electronic devices, take online courses, and even work. LifewareIntegra is made up of a core that converts a user's inputs into actions within the operating system. The core has a customizable interface that saves each user's options in their own personalized profile. The core works in the background, reading the inputs and interpreting them depending on which tool is in use. Our philosophy is to optimize each individual's abilities, so one expression can be used to control one action for each tool. The user can easily navigate between tools using them one at a time. This architecture increases the level of user interaction, making it an efficient and easy-to-use software. A disabled person must rely on assistance to be set up in front of the computer with the headset on, turn on the computer and initiate the program, all of which takes just a few minutes. First, the user selects their profile. Profiles are easy to create and customize. A diagnosis must be done to determine which expressions are most conducive to functionality. Some users may not be able to make a specific expression, and the diagnosis will determine that. The user simply selects the expression from a list and makes it. If the expression is detected by the software, it can be used. If an expression is not detected, a user can do a training to teach the software what his or her personal expression looks like. In a training, the user selects the expression they want to make and then records their version of this expression several times. The user must specify the degree of sensitivity for each expression and their resting state so that false positives do not happen. If a user cannot make many expressions, think patterns can be set. A think pattern can be trained by recording the neurosignals emitted when the user thinks up, down, right, or left. Next, the mouse and keyboard configurations must be set. The user links each expression or pattern to a specific action for each tool. For example, a blink may function as a right-click on the mouse. The movement of the mouse on the X and Y axes is controlled by the neck, and the degree the cursor moves can be scaled to the level of mobility in the neck. Shortcuts to other actions can be set here as well. Once the profile has been created, the program starts running. The main screen of the computer displays the status of the headset's saline sensors, battery level, and signal strength. We did multiple case studies during the course of development which helped us improve and expand our features. We know that quadriplegics can move their neck to nod and shake their head. These neck movements serve as a very precise mouse. They can also operate Windows 7 through our voice recognition module, making it possible to open and close programs, minimize or maximize windows, open a specific folder, or navigate to specific locations such as My Computer, My Documents, Desktop, and others. A virtual keyboard is optimized by our word prediction and hover-click features. We have also tested our software with ALS patients. Amyotrophic lateral sclerosis is a degenerative disease that destroys motor neurons, leaving patients unable to move their limbs, talk, or even breathe on their own. The majority of patients can control their necks to move their heads left to right, but not front to back. Their left-right movement controls our horizontal keyboard, so they can write and move through applications even with such limited mobility. This lateral movement of the neck can also move the mouse, and we can alternate between the X and Y axes so that their one movement moves the cursor horizontally or vertically simply by selecting Change of Axis. ALS patients generally never lose movement in their eyes, so their blink or wink can be linked to one action for each tool. In the most extreme cases, some patients' expressions are so tenuous that they're unrecognizable by epoch. To resolve this, we created the hover click. The patient holds the cursor in one place for a designated time, and a menu pops up with a list of actions like click the mouse, change to keyboard mode, or text-to-speech mode. Other useful features for ALS patients are our voice synthesizer and a remote control application which controls external electronic devices remotely via the computer using infrared technology. Users can control televisions, radios, DVD players, and even turn off and on the lights in their home. The extreme limitations of quadriplegia and ALS have been the driving force in our development and creation of new features. We also tested LifewareIntegra on people suffering from locked-in syndrome and other types of paralysis and have had successful results. As our user group expands and we continue to make improvements, our updater will allow us to automatically update the program so that users can benefit immediately from new modules we develop. We used several tools in developing LifewareIntegra, including Microsoft SAPI 5.4 to synthesize text-to-speech and voice recognition, and many other tools in the .NET Frameworks 3.5 and 4.0. In addition, we used Emotive Software Development Kit to connect our software to the Epoch headset. All of the interfaces have been developed in Windows Presentations Foundation, and we chose user-friendly options over aesthetics, keeping our target users' limitations in mind. When we started developing LifewareIntegra, we challenged ourselves to create a tool accessible to anyone who would need it, so the program can run on any computer that has Windows 7. LifewareIntegra was developed in 2010. During development, we collaborated with the Teleton Foundation, which supports children and young adults with developmental disabilities in their 14 clinics throughout Chile. It was started in 1978 and has been replicated in 13 countries throughout the Americas and Europe, forming the International Teleton organization, ORITEL. We met with disabled teenagers and the medical professionals who care for them to learn more about the specific challenges they face. Several of these teenagers served as case studies, helping us to refine and improve our features. At the beginning of 2011, LifewareIntegra was recognized by the National Service for the Disabled in Chile as an official technical resource for the disabled. Those living in poverty or on a limited income can apply for a government subsidy, and the Chilean government gives the software and the headset to qualified applicants. Our connections with Teleton and our recognition from the National Service for the Disabled have opened doors to new projects with rehabilitation centers and clinics around the country, which we are working on now. That is why we established our company, Lifeware, to manage, market, and distribute our software. Our goal is to provide LifewareIntegra to rehabilitation centers, hospitals, clinics, and other service organizations so that the program can be distributed through these channels to patients for use in their own homes. Our next step is to promote and distribute our software solution in other countries to institutions and organizations that specialize in assisting disabled people. We want to expand our market so that we can help as many people as possible worldwide. LifewareIntegra is a sustainable software solution that can improve the quality of life for so many disabled people. We see the capacity our software has to change people's lives, and that fact motivates us to continue working in pursuit of our goal, improving the quality of life of disabled people, allowing them access to education and employment. We expect the number of people benefiting from our software will increase more and more as time goes on, because we know LifewareIntegra brings disabled people closer to technology and its benefits. We at Lifeware imagine a future where our disabled brothers and sisters have the same opportunities for education, employment, and social integration as we do. We imagine a life where they are defined not by what they can't do, but where they have access to tools that focus on and function because of what they can do. Creating LifewareIntegra, we created a new life for the disabled.